Good afternoon, everyone. My name is Muhammad Ali from CML InfoTech. Thank you for joining, everyone. Today, we're talking about IP version 4 from Cisco CCNA, day 4, part 1. Welcome back. Today, we're talking about IPv4 version 4. IP Internet Protocol Address, IP address. This from layer 3 of the OSI layer, which is network layer, and it is a logical number. So there are IP version 4, IP version 5, which is omitted, and IP version 6. So currently we have IPv4 and IPv6 to study. So we'll start with the IPv4. So IP version 4, it is a 32 bits. So you need to understand the bit in bytes. So 32 bits dotted decimal format divided by 4 octet. So we'll explain this in detail. It's a 32 bits numbers, which is again decimal format with dotted. Or even we can say 32 bits or 4 octet. So which means, so if you look into this IP version 4 header, when you open IPv4 header, let's say we're gonna use Wireshark to understand. So when you open it, you can see few details in this. One we call version, talking about whether version 4 or version 6. Then you can see identification. The identification, which is equivalent to, we set in the sequencing number from the TCP IP or from the transport layer. So if I'm sending 5 pieces of data, I have to inform to the receiver I have sent only 5. So we'll put a number like 1, 2, 3, 4, 5. These numbers will identify from the transport layer in the name of sequence. But in network layer, we'll address with the identification. Then we have service types, which is again, we will be talking about QoS, quality of service, QoS. So which means if you're sending 2, 3 services together to the receiver, which one has to take a first priority? Like for example, if I'm sending video, I'm sending audio, and I'm sending data. So out of 3, which one has to go first? Or if I'm sending within data, I have 3 different data. Like for example, I have an email content, I have attachment content. So out of this, which one has to go first? Or if I have a HTTP content, I have a DNS content. Out of these 2, which one has to forward first? This is all talking about from the QoS, quality of service. So generally for an Ethernet interface or the LAN interface, we consider as a FIFO, first in, first out. Whoever comes first will go the first. Then also you can see source IP and destination IP. Even from the transport layer, you can see that source port and destination port. So let's say this is the Wireshark filtering content, which you can see like from the internet protocol, that you can see that source IP in the destination IP, and the version is 4. And you can see the protocol, which protocol used in the upper layer, which is TCP. Then you can see some identification number, which is in the hexadecimal to address that. Along with it, you can also see that the source IP and the destination IP. We can filter it in the later session today. Our hot topic today, talking about IPv4. Now, before we start writing IPv4, as I said, the IP version 4, has 32 bits. So first of all, you need to know what is bits. This could be a combination of 0 or 1. 0 means 1 bit, 1 means 1 bit. Like for example, if I'm writing 001. This means 3 bits. If I'm writing 10010, so it means 0, 1, 2, 3, 4. The total is 5 bits. This code called bits. So the way the IP version 4 will have 32 bits, and those 32 bits IP address from the combination of either 0 or 1. I request your full attention to here when we're talking about IPv4. So let's say, first we need to understand how we can write this 32 bits, or the bit in the sense, when I say bits, this is called binary number. Okay, so we have to learn binary, decimal, then hexadecimal. Okay, the binary is called 0 or 1. So 2 numbers. Therefore, we used to say the base of this binary, or the base of the binary called 2. And the decimal from 0 to 9, which is equal to 10. So the base of decimal called 10. And the hexadecimal from 0 to 9 and A to F. So this is 0 to 9, 10 number. Then A, B, C, D, E, F, 6 numbers. So total 16. So the hexadecimal, the base is called 2 raised to 16. We're going to write 2 raised to 10, something like this. So we'll start learning from a binary. So when we're writing a binary, we will start always from a 0. Okay, or we can write, yeah, then it comes to 1, 2, 3, 4, 5, 6, 7. It goes this way, 8, 9, 10, like for example. So if it is binary, then we're going to write 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. Okay. Keep deep intention to this to clearly understand. So this is called binary. Okay, 2 raised to 2 in the sense, you need to calculate 2 into 2 times. How much it comes? 4. 2 raised to 1 in the sense, we need to count 1 time. 2 into 1, it would be 2. 2 raised to 3 means we need to count 3 times of 2, which is 2 into 2 into 2, which is equal to 6. 2 raised to 0 means 1. So this will be 1, 2, 4. Then 2 into 2 into 2 means 2 into 2. This is 4. Then generally, when we count 2 into 2 into 2 means we count for the 6. But the reality, when you're talking about 2 into 2, 4. Then 4 into 2, 8. So this will become in the multiplication of previous number. Let's say here, if you look into this, you can see 2 raised to 0, 1, then double 2, then double 4, then double 8, then double 16. It goes in this way by adding a multiple of the previous number, which means now here we have 2 into 4. So 4 times of 2, which means 2 into 2s are 4, 4 into 2s are 8, 8 into 2s are 16. Now we have 2 into 5 times. So you need to count 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5. Or the 16, you need to multiply with the next number, which is called 32. So 2 raised to 6 means 64. 2 raised to 7 means 64 into 2 times, which is 128. Let's see, if I'm writing 2 raised to 8, what could be the number? 128 into 2 times, which is means 256. If I'm writing 2 raised to 9 means what will happen? 256 into double, which is 512. Then 512 into double, which is 1024. So this will go and this way, adding extra the same numbers, like for example, 1, 2, 4, 8, 16, 32, 64, 128, then 256, 512, 1024, 2048, 4000. This will go in this way. It's 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 6, 7, 8, 2 raised to 9, 2 raised to 10, 2 raised to 11. This will go this way by adding 2 to the power from 0 to upwards. 1, 2, 3, 4, 5. When you're adding an extra number, the previous number into 2 times. 2 into 4, 4 into 8, 8 into 16, 16, 32, like this. Okay. So thus, here, the 2 raised to 0, 1, 2, 3, this all called binary. Okay. Now, when you have a number, let's say 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. This could be anything. What I mean by anything, it could be either 0 or 1. But what meant by X? 0 or 1. Okay. So for example, if I'm writing, as you know, the binary, which means either 0 or 1. If I'm writing 0, 0, 0, 0, all are 0, which is equivalent to the output is also called as a 0. So this output, these 4 zeros are called as a binary. The output which I've mentioned, which is again 0 because of all are 0, this output will referred as decimal. Okay. Example, if I'm writing 0, 1, 0, 1, what could be the output? Wherever you have 1, which you need to calculate, wherever you have a 0, that is remain as 0. Example, here the 1, which is equivalent to 2 raised to 0, where will come like 1, because 2 raised to 0 means 1. Here 2 raised to 1 means actually 2, but because of 0, this will be remain as 0. And the 2 raised to 2, which is output called 4. 2 into 2s are 4. Because of 1, which need to calculate, that's called 4. And 2 raised to 3, which is 2 into 2 into 2, is equivalent to 2 into 2 into 2, which is equivalent to 8, because 2 into 2, which is 4, then 4 into 2, which is equivalent to 8. So it's supposed to be 8. Because of 0, it remains 0. So what is the output of here? 4 will add in between all the numbers. 0 plus 4 equal to 4, 4 plus 0 equal to 4, then 4 plus 1 equal to 5. So the outcome, which is called as a 5. So this is one of the easy way to convert from binary to decimal. Let's see if I'm giving you an example. 1111010. What is the OR? You can, the easiest way, 11110. 1 0 1 1 0. This is my binary. The binary either could be 0 or be 1. So what could be the decimal number of this binary? How can we easily address it? So you need to write on top of it the respective binary values, which is 2 raised to 0. Always start from 2 raised to 0, then 2 raised to 1, then 2 raised to 2, then 2 raised to 3, then 2 raised to 4, then 2 raised to 5, then 2 raised to 6, then 2 raised to 7. Now, this is 0 because of 0. This is 1, so we have to write the actual value of 2 raised to 1, which is 2. 2 raised to 2 because of 1 is equal to 4. 2 raised to 3 is because 2 raised to 3 is 8, but we cannot write 8 here because the value of the binary, which is 0, so it remains 0. 2 raised to 4, which is, so let's say we can put this 0, 0, 1. Let's say 2 raised to 4 means 16. Then the 16 plus 2 raised to 5 means 16 into 2, but 2 times of 16, which is 32. But because of 0, it remains 0. And 2 raised to 6, it's a 32 into 2 times, which is 64. But because of 0 will remain 0. Then 2 raised to 7 is 128 because of 1. 2 raised to 7 means 128. Then because of 1, we are writing here as 128. So 128 plus 0 plus 0 plus 16 plus 0 plus 4 plus 2, 0. So what could be the output? The value which comes, the output is the output as called decimal. Okay. The way on the next session, you need to write a homework of binary to decimal. I'll give you the homework at the end of the session. So by doing this, hope you understand the binary conversation. So let's say so here you can see 2 raised to 0, the output of the binary respective values. So this is what I said, that 2 raised to 1, 4, 8, 16, 32, 64, 128. I think this document I have already shared to you. So one of the easy way to address the binary values. So here you have an example, like for example, here is a 0, which is equivalent to 0 on the first one, example 1. So you can go through this document later today. Now, why do we wanted to learn this binary conversation? Because we are going to learn the IPv4 conversation. IPv4, what's IPv4? How we can write the IPv4. So in order to write the IP version 4, we need to know how an IPv4 can be accommodated. So basically, the IP address, either v4 or v6, these are binary numbers. And IP version 4, even if it is binary, we generally focus with the decimal values. So by going through this binary to decimal conversation, you need to understand how to convert from binary to decimal. Hope these 2 examples can help you to understand more. And I recommended you to go for a more exercise, which I can give you on the end of the session. Now, we'll go for how to write IPv4. As I said in the very beginning, IP version 4, 32 bits. And these 32 bits will be divided into 4 times of 8 bits. 4 times of 8 bits. So one group of 8 bits total, we can call it 1 byte. Okay, let's say the bits or the binary digit could be either 0 or 1. Let's say, for example, I'm going to write 1 1 0 0 1 1 0 0. This is total 8 bits. 1 2 3 4 5 6 7 8 8 bits. The 4 bits together, we call it as one nibble. The 4 bits together, we call it as one nibble. Okay? The full 8 bits is called as 1 bytes. The difference when you're writing bytes and bits, when you write bits, you need to write small letter b, and when you write bytes, you need to write capital B, 1 byte, also known as 1 octet. 1 octet. So 1 octet is equivalent to 8 bits. So the 4 octet, which means 8 into 4 times, which is 32. This is called the IPv4 address. So the IPv4 address, either 32 bits binary or 4 octet. Then these 4 binary or this 4 octet, which is binary, we cannot address it. The IPv4, even if it is binary, it will be converting into a decimal. So let's say I have a 32-bit binary number. Example, I'm going to write 1, 2, 3, 4, 5, 6, 7, 8. 8 binary. 1, 2, 3, 4, 5, 6, 7, 8. 8 binary. 4, 8. 8 binary. 8 binary. What's the total number now? 8 into 4 times, which is 32. Okay. And after every 8 bits, there's a dot. So the IP address will be start from 0000. Okay. And end up with 1111, 1111, 8, 8, 8, 8, which is 32. So it could be the combination start from a 0, end up with 1, or anything in between 0 or 1. Example, what could be the next number? All zeros, then this would be 1, which is equivalent to 1, because this is, let's say, this is 2 raised to 0, this is 2 raised to 1, 2 raised to 2, 2 raised to 3. So this is 1, which means all the remaining are zeros. What is the next number? All 0, all 0, all 0, then here 0, 0, 1, 0, which is equivalent to 2, then 3, then 4, which is 1, 0, then 1, 1, 0, 1, 0, 1, 1. The way it will be increased and will be reached until 1, 1, 1. So what is the outcome of this? When I say 0, 0, 0, 0, this would be whole 0 equivalent to 1, 0. Whole 0 again 0. Whole 0 again 0. Whole 0 again 0. So the 4 zeros. Start with the 4, 0 and end up with whole bits are turned on. What does it mean? Like for example, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7. Do not read 26, 2 raised to 6. Now, I said 1, 2, 4, 8. Okay, I'll write the bottom of 8 bits individually. 1, 1, 1, 1, 1, 1, 1, 1. How many? 1, 2, 3, 4, 5, 6, 7, 8, which means 2 raised to 0, 1, 2, 3, 4, 5, 6, 7. 2 raised to 0 means 1, 2 raised to 1 means 2, 2 raised to 2 means 3. Oh, what is 2 raised to 3 means? 4, and the double 1, 2, 4, 8, 16, 32, 64, 128. So all are turned on, all are on. So we need to calculate all the values. So what is the result of all this adding? 128, 64, 192, 224, 240, 244, 248, 250. It will become like this by adding all these values. And if you're going to be end up with when all 8 bits are turned on, your output of this value will become 255. Do one thing in the calculator, you can calculate 128 plus 64 plus 30. You do calculate by yourself, you're going to get the value called 255. Okay, so let me calculate this by the way. Calculate. Sure. Okay. We'll do. Hope you can see my screen. I'll calculate. Yeah. 128. 128 plus 64 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. To check here, let's be adding 128, 64, 32, 16, 8, 4, 2, 1. It is altogether 255, which means your IP address will be starting from 0 and it will reach up to 255. This is one octet or 8 bits, the way 0 to 55, 0 to 55, 0 to 55. So this is your IP address, IP version 4 or any IPv4 address. You cannot write all 0 and even you cannot write all 255. When all 255 means your all bits are on. This 255 in the sense your all bits are on. All bits are on. When your all bits are on, the all bits output, which is 255 in decimal, will considered as broadcast. And IPv4 or IP address is a network layer, layer 3. So the layer 3 broadcast means when all bits is turned on from the IPv4. Okay, and all 0 we cannot consider, which means we always start the IP from 1 after 0 and 254 before 255. So this is our valid IP. Okay, 1 to 254. Hope you understand. Now, this 1 to 254 valid IP, which is this is what I meant. You can see that 128, 16, 24, and 32, which is start from complete 0 because the binary is completely 0. Then the binary, when it comes completely turned on, the decimal of those binary will be getting to 255, 255, 255. This value, which we explained in the board. Hope you understood. Now, the 0 is already reset. We're talking about how to identify the host portion. Then the total IPv4 address, which includes 0 to 56. From that, 0 and 255 are reserved. So the remaining IP valid IP range are from, it must be 1 to 254. Now, when the whole IP address, IPv4, there's a 3 area. One we call the network and one we call the host. And the prefix, which is already included in the network. Therefore, we can address it either the IPv4 are 2 area, one called network, one called host. Or we can say prefix network host. The prefix is built in with the network. So those IPv4 address, which is 1 to 255 valid IP, are divided into 5 classes. Class A, B, C, D, E, and D and E. The D and E are not generally used, which means the E is used for research purpose. And the class D, we are using class D for routing purpose, which is called multicast. I'll let you know what is multicast. There are three, generally there are four: unicast, multicast, broadcast, and anycast. We will learn shortly, inshallah. So we are generally using the classes from class A, B, and C. And for all these classes, there are 4 portions, like first 8-bit, then that, then 8, then 8. So from those IPv4 address, if you've taken about any classes, there are 2 areas, either network or host. Okay, either network or host. I'll let you know what's the difference between them. So here, if you look into this, in the class A, there are certain value, which is 0, 10, 110, 110. These are reserved number, which I said in the very beginning, which is prefix number. So here, let's say, for example, we will talking about class A first, then we go for class B, then we go for class C. So there are certain numbers being reserved already. The class A, which is reserved from 1 to 126. So if you're looking at the number, anything start with 1 to 126. This is always referred as a class A. Any number, which means, let's say, as I said, the IPv4 from 1 to 254 valid address. And any class, and these 1 to 254 are reserved in class A, class B, class C, class D, and class E. And this 1 to 254, which is 1 to 126, is class A, 127 to 128, class B, and 128, so 120. $191. So by going to look at this 1 to 126, out of 1 to 254, anything which is start from 1 to 126, if you saw that, then you need to understand that's a class A IP. We'll explain this in detail on the part 2. So thank you for joining with us. We just explained about the binary conversation, and we're going to start with the IPv4 class A address details. Hope you enjoyed the session. Thank you. Have a good day.